Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 15 of the Geeks for Geeks problem of the day, and we have an easy level question in front of us. Let us see what the question is. It's question reach the nth point, okay? Uh, First let's see the input and output, then we'll try to understand what the question is, okay? So we have given integer input which they're calling as n, and again we have written integer output only, okay? So only one integer and only one input and only one output, okay? Now let's see what the question is. They are saying there are n points on a road, okay? And you can move from a one point, you can move to the next point, or to the that is, you can move by a step of magnitude 1 or by a step of magnitude 2, okay? That means if you are at point 0, you can move by a step of magnitude 1, that is you can go from 0th point to the first point. Or if you try to move by a step of magnitude 2, okay, that means you are at point 0, you can go to point 2, okay? These are the only two possibilities, okay? Either the step should be of a magnitude 1 or it should be of a magnitude 2, okay? They have given a sample example also. If you start from point 0 and move by from point 1 to point I plus 1 by a step of magnitude 1, you can go through that, okay? Just go through it. There are some samples given here, we'll discuss this also. But yeah, uh, okay, this point also I have to discuss, but let us see the example first, okay? For example, I'm at point 0, okay? Though they have not directly mentioned it, in this problem, if you have to solve it correctly, you have to assume that you are starting from point 0, okay? Yeah, starting from point 0. So what you're doing, see, let's try to understand this example first, okay? I'm at point 0, I will move by a point of magnitude 1, okay? I will reach point 1. From point 1 again, I'm going to take a step of magnitude 1, I'm going to reach point 2, okay? From point 2 again, I'm going to take a step of magnitude 1, I'm going to reach point 3. And from point 3 again, I'm going to take a step of magnitude 1, I'm going to reach point 4. These are the one ways. The other way is that from point 2, so that is from point 0, you can take a step of magnitude 2 and reach point 2 directly. And from point 2 again, you can take a step of magnitude 2 and you can reach point 4, okay? So like that, there are many approaches here. And just remember one thing, we are starting from point 0 and we have to reach point 4, okay? The possible magnitude of steps are 1 and 2, okay? That's what it is. And remember, since the answer can be a bit larger, what they're trying to do is you have to return the answer modulo 10 power 9 plus 7, okay? And the expected space and time complexity are O of n and O of n, okay? I will show you a solution for this space complexity, and then I will show you even a better solution. Method remains the same, but you can modify it in such a way that it becomes O of 1. That is a constant space complexity. I will show you that also, okay? And this number can be a bit larger, from 1 to 10 power 5, okay? That's the constraints. For complete tags, you can go you can see by yourself. Let's come to the solution first, okay? So for some of the base cases, I have defined the solutions directly. That is, for n equal to 1, the answer is going to be 1. Okay. That is, from 0, you have to go to point 1. That means there's only one way. Similarly, if from 0, you have to go to point 2. Okay. There are two ways. What are the two ways? From 0, either you can go to directly to point 2 by a magnitude of step 2. Okay. Or you can go to, from 0, you can go to point 1 and then to point 2. Okay. So there are two ways. Then for cases greater than that, okay, the cases where n is greater than 2, only will come to this part, okay? This part will execute only for n greater than 2, okay? So what are that? See, I'm going to define array here, which is of length n, okay? Initially, all the values in that will be 0, okay? All the values will be 0. So what is my ideology is that possible paths of I, okay? That is, the ith index of this array is going to be the number of ways to reach the index n from the index I, okay? So for example, possible paths of 5, that is, possible paths of 5 is the number of ways to reach the index n from the index 5, okay? So I'm giving two values in that also additionally, okay? For example, if I'm at n minus 1th index, okay, n minus 1th, that means I have to reach index n, and I am at n minus 1th index. Then how many ways I have? Obviously, I have only one way. Please understand it properly. If I'm at index n, and if I'm going to start from index n minus 1, I have only one way, okay? Please understand this definition correctly. Please, you need to pause the video maybe or rewind the video maybe. See, because if you are a beginner, these things will take time. Definitely it will take time, but I'm assuming this video will the audience of this video will be either beginners or even the intermediate ones, okay? That's why I will show my way so that you can get some ideas. But if you are a beginner, you will have to dig in some part, you will also have to put some efforts, okay? That's what I'm expecting. See, the possible paths, from if you are starting from n minus 1 and going to n, there are only one way, right? Similarly, if you are going to start from n minus 2 and your target is n, okay, there are two ways. What are the two ways? Either you can directly go from n minus 2 to n, so there are that is the one way, or you can go from n minus 2 then to n minus 1 and then to n, okay? So there are two ways. And this is the model which they have mentioned. I'm defining the same way. In Python, if you have to get 10 power something, you have to use double stars, okay? That is one thing. Then, as I mentioned, I have the answers for n minus 1 and n minus 2. So I will start getting the answer from n minus 3 onwards. This for loop will start from n minus 3. It will go till 0. It will go till 0. and it will be a reverse for loop. That means if I have I in this loop, it will be I minus 1 in the next loop. Okay, that's what it is. In Python, we define it this way. If I write -1 here, then the loop will go till 0. Okay, what I'm doing is I need to find the possible paths of I. How should I do that? See, from I can go to only two places. There's I plus 1 and I plus 2. Okay, so I will find the number of possible paths of I to the index n is going to be the possible paths of I plus 1 plus the possible paths of I plus 2. Okay, and again I'm doing this modulo. See, the idea here is I don't want to store the bigger number. I will simply do it by modulo, then I will store the answer. That's what I'm doing. See, please follow with me. This number modulo, this number again a modulo, the whole answer again a modulo. Okay, that's what I'm doing here. Okay, then it will become possible paths of I. Okay, initial for the first loop I will be n minus 3. Okay, so by the end of the first loop I will have the answer for n minus 3 onwards. Similarly, it will go till index 0. Okay, the last loop will be for I equal to 0. Okay, and then that answer I'm going to return. Okay, that's what it is. So please try to understand what I'm doing. I have the number of ways from -1 and n-2. Then I will try to find from what is n-3, and then for n-4 and till then I will go to index 0. I will just quickly run and show that you will have a better clarity. Okay. So yeah, just bear with me. See, this is the index 0, this is the index 1, this is the index 2, this is the index 3. Okay, our target is to reach index 4. Okay, so from index 3, I can reach index 4 in one way. Okay, similarly from index 2, I can reach index 4 in two ways. Okay, either I can from 2 I can go to 3 and then 4, or from directly I can go to 2 to 4. So there are two ways. Similarly, from index 1, what are the ways? See, from index 1, either from index 1 I can go to index 2. Okay, from index 1 I can go to index 2. Okay, so this will be added. Okay, definitely. Then from index 1 I can go to index 3 also. Okay, by a step of magnitude 2. So ultimately we'll have to add these two answers to get the answer for this. Okay, similarly for index 0, what are the possible ways? From index 0 I can go to index 1, or from index 0 I can go to index 2. Okay, so what are the ways? From index 0 I can go to, from come to these two. So what are the paths from this to the last? That I will simply add. Okay, so for index, getting the answer for index 0, I have to add these two. Okay, if you are 3 plus 2, you will get 5. Okay, then this is going to be the ultimate answer. That was my approach. If I simply comment it out and run and show you, you can see that it's getting accepted. Okay, so remember, in the X4, this is one of the disadvantages that if you are newer, let me tell you that even if you return the correct answer, you will mark as a wrong answer because you are printing something else. Okay, so you have to remove all the prints before submitting the final answer. You can see the answer is getting accepted here. You can submit it for yourself and you can check. Okay, so these are one of the ways. The way they have asked it, okay, it is of O of n space complexity. Why? Because we are defining a array of O of n. Okay, of length n. Okay, and again the time complexity is also O of n because almost n steps this solve is going to take. Okay, almost, I'm not saying like that, almost. So this is also O of n time complexity. Okay, now I will one thing which you might have observed in this is that at any step, at any index I only require the answer for I plus 1 and I plus 2. I'm not going to need anything more than that. Okay, I'm not going to need anything more than that. So for the calculating the answer for the ith index, I need the value for the I plus 1 index and I plus 2 index. Okay, so I do not need the whole array basically. So if you try to think of a possible optimized approach, you will come to this. Okay, so what I'm doing here, please take a screenshot of this maybe so that you can differentiate and understand. Okay, see, the range here is 3n. Okay, the range here is n. Now what I'm going to do is I will make it 3. As I mentioned, I need only for ith index I need only I plus 1 and I plus 2. Okay, that's what I'm going to do now. Okay, then this will become like this. Okay, so for the last index, that is from, see, suppose I am at index 2, I have to go to index 3. What are the ways? Only one way. Similarly, if I am index 1 and I have to go to index 3, what are the ways? There are two ways. Okay, so what I'm doing, see, this step remains the same. Okay, this step what I will do is for index 0 I have to calculate, I have to add the path of index 1 and then I have to add the value in index 2. Okay, that's what it is. Then I will shift the values. What I will do, whatever is the value in index 1, okay, take it to index 2. Okay, whatever is the value in index 1, take it to index 2. Okay, similarly, whatever is the value in index 0, take it to index 1. Whatever is the value in index 0, take it to index 1. Okay, similarly, so what I'm trying to avoid here is that, see, instead of having a big array like this, you might be seeing that the and it can be 10 power 5, right? Instead of having 10 power 5 elements in array, I can have only 3 elements and still I can get the answer. Okay, if I run and then show you this, you can see that it's getting accepted. Okay, yeah, it's getting accepted. Okay, so but the idea here is I'm trying to reduce the space complexity here. Okay, instead of having an array of where n can be 10 power 5, that is having 10 power 5 elements, I can have only 3 elements and still get the answer. why we are thinking of this, because I got to know that for any index I need only two values to get the answer. Okay, that is the I plus one value and the I plus second value. That's what we are doing here, and the approach is very similar here. Okay, the approach is very similar here. Only thing is, instead of see, I only need I plus one, I plus two, right? So I'm simply storing them, and I am reversing them at times. So once I got the index 0, what I will do is I will shift the one value. I will shift the one value to the second place, and I will shift the 0th value to the first place, so that now index 0 is again empty. The index 0 will be calculated in the next index, and so on. Okay, and so on. And ultimately we're going to get the answer 0. Okay, this answer also getting accepted. So yeah, fine, that was all for today. This question was marked as easy. I hope after going through my solution you will feel it is easy. And if you want to solve similar problems, okay, there are other websites also, like leetcode and other websites. I uploaded the solution for leetcode also in my YouTube channel. You can go through it. It's also easy question. Basically, the destination city, they're using a graph concept here. If you like to solve more, you can go through this also. I've given a detailed approach here, using sets of Python and all those things. Hashing concept, basically it's called the hashing concept. And this today's solution, the concept which I've used is basically the dynamic programming with memoization. Okay, the dynamic programming with memoization. This is basically a way of catching the results and using it again and again. Okay, so yeah, friend, that was all for today. I've gone through the time and space complexity, and I've explained to you optimal solution as well. Okay, in interview, always start from brute force approach, then go to a optimal, a better solution, at last go to optimal solution. That's what it is. So yeah, friend, that was all for today. Yeah. Hope to see you tomorrow. Thanks a lot.